All right, we're back. I hope you had a time to go through and factor each expression so you can check your answers, whatever method you want to do here. Let's see, the first one, I'm going to use the famous box method. So 8x minus 16. Divide that in half. Greatest common factor is 8. What's left over is x minus 2. So my final answer would be 8 parentheses x minus 2. Gilbertson, you want to do the next?
Sure. I'm just going to do the greatest common factor method.
Okay.
So I look at 3x squared and 12, and I see that the greatest common factor that these share is 3. And so if I divide 3x squared by 3, I just get x squared. And if I divide 12 by 3, I get a positive 4.
Perfect. On to the next one. Mr. Grev, go for it. What method do you want to use? Don't say algebra tiles, please. Don't say algebra tiles.
Okay, we won't. Okay, so I'll just think of the greatest common factor that these both have and try to pull that out. Let's see. Here we have is that x squared and a 5x. I think both of these are going to share a greatest common factor of x. So pull out an x, and we divide an x out of both of them. Let's see. If x times something is x squared, it must be an x. Is our first thing here. And then something times x is 5x, that must be plus 5.
All right. And you guys, we can always check this by expanding back out and checking to make sure that we actually get the same solution. So that means that you should not get anything incorrect on the test.
Not even one thing?
No, not one thing. Nope, because you can check your work. All right, I'm going to use the box method here. I have two terms, so I have 2a squared minus 10a. I'll split this guy in half. I know that my greatest common factor is 2a. So this one I need to multiply by a, and this one I need to multiply by negative 5. So this should be simplified to 2a, a minus 5. All right. Whoa, that looks complicated. But have no fear. Have no fear. We're going to do number 6 first. Because that one's totally a little bit easier. We'll come back to that crazy guy. Yeah, let's do that. Okay, here we go.
Well, if we tried to do the greatest common factor, we'd have to find the greatest common factor of 3 different things, right?
Oh, we can do it. We can do it.
Let's see. I'm going to start by just looking at the numbers. So 5, 10, and 25. And I know that each one of those has 5 as a factor.
Let's look at the variables. Z squared, Z, nada.
So it looks like z squared and z squared.
Oh, so what should we do before we even pull out a greatest common factor?
Oh boy. We should maybe subtract and combine the like terms.
Wasn't that a note on the first page that we totally ignored? Let's look here. Yep. Before factoring, always simplify first. Gosh, you guys should listen to instructions.
Sorry, my bad.
All right, whoa, that's the wrong page. Here we go again.
Okay, so let's try again. So 5z squared minus 10z squared is negative 5z squared. And then we just leave that plus 25 the way it was. But I stick with it that the greatest common factor here is still 5.
Okay, you're right. Let's go ahead and take out that GCF as a 5. We would be left with?
Negative z squared plus 25.
Okay.
Oh, not 25.
No, you're wrong.
I'm sorry, my bad. Plus 5. I forgot to divide.
Don't you love when teachers make mistakes? And there's not just one of us either. There we go.
Much better.
Let's go back to this one. I'm going to start by making sure I can't simplify. P squared, PQ, and Q, they cannot be combined. So I'm going to take out my greatest common factor. Greatest common factor is 3. So if I divide 3 out of every single term, I have p squared minus 3pq plus 9q squared. And we're not going to go any further than that.
Perfect.